Simplify the square root of 54c cubed. Now, neither 54 nor c cubed in themselves is a perfect square, but each of them has a perfect square factor. So what we're going to do is we're going to split both of them up so that the perfect square portion goes under the first square root sign, and then whatever's left over goes under the second. Let's start by looking at 54. We need to factor 54 so that the first factor is a perfect square. And 54 is 9 times 6, and 9's a perfect square. So I'm going to write that 9 in the first square root, and then the 6 in the second. Now, c cubed is not a perfect square, but c cubed contains c squared as a factor, and c squared is a perfect square. So we're going to write c cubed as c squared times c, and we're going to put the c squared in the first radical, because the perfect squares go in the first one, and then whatever's left over, in this case the c, goes in the second radical. Now, under the first radical, we can evaluate those. The square root of 9 is 3, and the square root of c squared is c. So because that's a perfect square, we can evaluate that square root as 3c. And then the leftovers are stuck inside the second radical. The 6c is not a perfect square and does not necessarily contain any perfect square factors. So there's nothing more we can do to that. And this ends up being our final answer, 3c times the square root of 6c. In general, in a situation like this, the standard is that we take anything outside of the radical, and that goes out front, and then anything left inside the radical goes at the end. Usually, we're used to having the coefficients in the front and the variables in the back, but because the square root separates the coefficients into the inside and the outside, and it also separates the variable factor, we use a different rule here. And so we'll put everything outside of the radical first, and then whatever's inside the radical, that will go at the end.